Welcome again, ladies and gents. Today what we're going to focus on is how to identify the numbers that matter in a measurement. And those numbers that matter are called significant figures. So how do we figure out what those are? When we talked about measurement, we talked about how you have to go one past what your measuring device gives you. And that's exactly what our definition of significant figures tells us. A significant figure is going to be from a measurement that includes all numbers that are certain plus one digit that's estimated. So just a quick reminder from measurement, if we look at ruler A, our certain number is going to be the one spot. Because our aluminum rod falls between 4 and 5, we know our certain number is 4. Our estimated number comes in the estimation between the 4 and the 5. So we could estimate this as 4.2, 4.3. So our significant figures would be 2 in this measurement because we have our number 4 that is certain and our number 0.2 that is estimated. If we look at ruler B, because we've increased the markings, we can increase the numbers that we measure. So in this case, our certain numbers are going to be the 4.2 because I now have those markings. But my rod falls between the 2 and the 3, so this is where I can estimate about how far along that aluminum rod actually is going. So I could call it 4.25, 4.24, 4.26. Any of those would be good estimations. So if we compare the significant figures in these two measurements, ruler B gives us more numbers, which gives us a more precise measurement, which means we can do better math with that number when compared to ruler A. So our significant figures directly ties into the ability for us to get great math. Now remember, if you're reading a volume, you read from the bottom of the meniscus. So in this measurement, we've got 6 here at the bottom, 8 here at the top, which means this middle line is 7. So each of these are an increment of 2, so 0.2, 0.4, 0.6. This meniscus falls at exactly 6.6. And remember, if you fall exactly on that line, you throw a 0 at the end to show that you hit the exact measurement on that graduated cylinder. So 6.60 would be our measurement for that. And it's super, super important that you remember to put a 0 on the end if you fall exactly on the marking. So our ability to measure is what impacts our Sig Figs. Now there's rules that we can use to determine what numbers matter when we're looking at a measurement. So the rules that we can use help us identify what numbers matter in a measurement. And the first rule is really, really easy. When you're looking at a measurement, if there are no zeros present, all the numbers are significant. What I'll often ask you to do is to count how many significant figures are present in a number, because that relates to our math. And we'll talk a little bit more about that later. So when you're looking at a number, if all the numbers are integers between 1 and 9, they're all going to be significant, so they need to be counted. So in the measurement 1457, we would have 4 sig figs here. In the measurement 12, we would have 2 sig figs here. In the measurement 13,245, we'd have 5 sig figs here. In the measurement 135, we would have 3 sig figs here. So when you have no zeros present, it's super easy. All the rest of the rules are going to determine when a 0 counts and when a 0 doesn't count. So let's move on. Our next rule talks about captive zeros. If you're held captive, it means you're a prisoner in something. A captive 0 is going to be a 0 that's a prisoner in the middle of a number. So what that means is you'll have an integer on the front that's not 0 and an integer on the back that's not 0. So anything between those two integers is going to be significant. So I call this the Oreo cookie rule, because if you've got an Oreo cookie on the front and an Oreo cookie on the back, all the stuff in the middle is good because the cream's the best part, right? So our Oreo cookies are going to be the non-zero numbers. So if we look at this first number, 6.303, we've got a non-zero number on the front, we've got a non-zero number on the back, so everything in the middle is good. So we would have 4 sig figs there. If we look at the number 5.002, we've got a non-zero on the front and a non-zero on the back, so everything in the middle is good. So we'd have 5 sig figs there. And in 5005, we've got a non-zero on the front and a non-zero on the back, so everything in the middle is good. So we'd have 4 sig figs there. So rule 1, all non-zero numbers are significant. Rule 2, if you have the zeros sandwiched in between two non-zero numbers, they are significant. So what if we have zeros that happen to fall outside those non-zero numbers. How do we know if they matter or not? Our first rule for those types of zeros are dealing with what we call a final zero. Our final zero is going to be at the end of a number and to the right of a decimal place, meaning they're going to be at the end of your measurement. So if we think back to that first slide, we had 6.60 milliliters. This zero would be considered a final zero. We had to put it because we landed exactly on that line for our graduated cylinder. So we had to show the person with that zero that we hit that line exactly. And Pri is so excited to be learning Sig Figs, he's whining in the background, so I apologize if you can hear him. So if we look at these numbers, if you see that zero at the end, what it means is you hit that mark exactly. So it doesn't really matter how many zeros are in front of it because it's like the new end of your Oreo cookie. So we find the first number we have in the front, we find that final zero, and everything in the middle is good again. So this would have 5 Sig Figs. We have a decimal place with a zero at the end, so this zero is significant. The one in front is significant, so all the stuff in the middle is good. So that would be 4 Sig Figs. We have a zero on the back, a 9 in front, so that's all we have. So we would have 2 Sig Figs. So if you have a decimal place and you have a zero at the very, very end of your number, the stuff in front of that is going to be significant. Now, let's talk about when zeros don't count. Zeros do not count if they're what's called a placeholder zero. What a placeholder zero is going to do is it's just going to hold value for us in our number. So, for example, if we have a really, really big number, your placeholders are going to be found to the right of your non-zero numbers. Now we need them because in this measurement, the only number that counts is that 3 in 300. We need these 2 zeros because saying the answer is 3 versus 300 has a very, very different quantity to it. So even though the only significant figure is this number 3, it was found in the hundredth spot. So we need to add those placeholder zeros to make sure that this has the correct value. So for your big number, those zeros are going to be in the right side. So in 300, we only have one significant figure. In 27,210, these are going to be our significant figures. So we would only have 4. And in 12,000, these would be our only significant figures. So we would have 2. So if you do not have decimal places, notice these do not have decimal places. If you do not have decimal places, those zeros are going to be placeholder zeros. Now, if you have really, really small numbers, your placeholder zeros are going to be found in the front because these guys are simply holding place for us, so they do not count. So one thing that I like to think about is if you're dealing with zeros and decimal places, here's my rule that kind of summarizes everything we've talked about. If you have a decimal place, find your first number that's not a zero, because no matter what comes after it, it's going to be significant. So this would have 3 Sig Figs. We have a decimal place. We have a decimal place. We find the first number that's not a zero, and everything that comes after it is significant. So that would have 2 Sig Figs. We have a decimal place. We find the first number that's not a zero, everything after it becomes significant. So this would have 4 Sig Figs. I like that rule because what it does is it encompasses everything we've talked about. Because even if we look here at this number, 43.000, we have a decimal place, so we find the first number that's not a zero, and everything behind it counts. So when you have decimal places and zeros, just look for where your first integer between 1 and 9 is found, because that's going to mark the start of your significant figures, and everything after it, no matter what, is going to be significant. When you don't have decimal places, that's where you can have zeros at the end of a number that will be placeholders. So part of your homework after this video is to try the front side of that worksheet by underlining all the numbers you think are significant, and we're going to start class with that tomorrow. Now, one thing we need to be able to do is we need to be able to understand other ways that we can show Sig Figs. So for example, we used a scale and we knew the mass of our canister was exactly 300 grams. How do we show that since we were exactly 300, that those zeros count? There's three things you can do. The first thing you can do is you can put a decimal place at the end. Because by putting a decimal place at the end, it's kind of like that rule we just talked about. Here's our first non-zero number, and everything behind it counts. So those zeros will become significant. So the first thing you can do is you can go ahead and you can put a decimal place at the end. The second thing you can do is you can put a line over the last zero that's significant. So that's going to show you where your zeros stop counting. This is really good for big numbers. Let's say, for example, we only wanted this to have 3 significant figures. So this 0 would be our last sig fig. All these other zeros would be placeholders. So the line method is very, very good if you have a very large number, because you can show exactly what 0 stops counting. The last thing you can do is you can put it in scientific notation, because putting something in scientific notation shows you exactly what significant figures you have, because we now have a decimal place. So this 3 counts, and so do all the zeros behind it. So these are the 3 things that you can do if you have something with zeros that you need to count. You can put a decimal place, you can put a line, or you can put in scientific notation. I don't care what way you choose, you just got to choose one. All right. Now, if we have something called a counting number or a constant, these are going to be things like if I have 24 students in class, or you have 13 pens in your pencil case. Those are things that are counted, and they don't have a sig fig amount. They're considered to have an unlimited number of sig figs, and we'll talk about why that is later next week. So if you have a counting number, so something you physically counted, or something called a constant, it has an unlimited number of sig figs. And this is a very, very important rule because you're all going to forget it and you're going to get it wrong on the test. So make sure you star this rule. So examples of counting numbers would be like saying you have 8 apples in your refrigerator, there's 24 students in your class, or you have 13 pencils in your pencil case. A constant would be something like a conversion factor. So I know that in 1 inch there's 2.54 centimeters. So this is kind of an equality. It's a way that I can go between inches and centimeters. So this has an unlimited amount of sig figs. 12 inches in a foot, the same idea, has an unlimited amount of sig figs. And 1,000 milligrams in 1 gram is the same idea. So anything that you can count or anything that you can use to convert is going to have unlimited numbers of sig figs. Now the last thing we want to do is we want to talk about rounding. Rounding is just like what you did in math. Anything that's 5 or higher gets rounded up. Anything that's 5 or lower gets rounded down. So I'll go ahead and now do the first one, and I want you guys to try 2 and 3. And what we're going to do is we're going to round these things to 2 sig figs. So when you're looking at a number, if you're rounding it, find where you have to round. So in this case, we're going to round them all to 2 sig figs, and you look directly behind it to round. So in this case, 2.533, that 3 is below 5, so my answer would remain 2.5. Go ahead and hit pause and try and round the next 2. All right, I'm assuming you've taken the time to go ahead and round these 2, so I'll walk you through the process just to make sure. This is higher than 5, so this would become 5.9. And this is lower than 5, so this would remain 6.2. I hope you found this helpful. Go ahead and fill out the questions on your Google form right now, and we'll talk about these sig fig rules. Also, don't forget to do the front side of that half sheet because that's what we're going to use in class to go over a lot of your questions. Good luck, guys.